Okay, we're going to look at the first question here. It says that a radar device tells an operator that a motorbike is moving according to this equation. Stands for distance, which is weird. At any given time is 1 over 15 t cubed minus 2t squared plus 20t. They say t is in t, sorry, S is a distance cover and T is the time in seconds. Ooh, I better make this a bit smaller. I cut it off a bit. It's the time in seconds. So this whole thing is how many meters it's gone after a certain time in second. We know that if we take the derivative of this equation of distance, we get speed. And if we take the derivative again, we get acceleration. So let's just try it. How fast is the bike traveling when first detected? Well, how fast is when it's first detected? That means we've got to take the derivative of the distance formula here to get the velocity. And if we take the derivative, 3 times 1 over 15 is 1 over 5. Bring it down 1t squared. 2 times minus 2 minus 4t. 20t is just 20. There's the equation. We let t equal 0. We put 0 in there, and we get the velocity at right in the beginning is 20 meters per second. So the velocity of the bike when first detected is 20 meters per second. Okay, the next question says, show that the bike did stop. Well, you have to think to yourself, well, there must be a time when the velocity is 0. So you take that same equation and you just make it equal 0. And then you solve it. You multiply everything by 5, you get this equation. But t squared minus 20t plus 100 is really t minus 10 squared. So t must just be 10. The bike did stop after 10 seconds. Let's look at the next question. Determine the distance covered while being tracked. So we want to figure out the distance that it traveled. Let's see here. The distance covered in these 10 seconds. So how long did it go in 10 seconds from 0 to 10? All we have to do is go back to the formula for distance. And the formula for distance is this one right here. And so all I did was take that formula. I'll just put it down here so we can take a look at it. I just took that formula and I put 10 in there. I just put 10 in there. And I put it in my calculator and I got 66 and 2/3 meters before it stopped. Okay, the next question. So just put 10 into the distance formula. About acceleration. Determine the acceleration of the bike at 5 seconds. Well, if I take the derivative of the distance one, I get this one here, velocity. But if I take the derivative one more time, I'll get acceleration. So that's what I've got to do. I take the derivative, whoops, went the wrong direction there. I take the derivative one more time. Sorry for all this flipping around. I've got this equation, which is, let's go back and get it actually, 1/5 t squared minus 4t plus 20, and I take the derivative of it. 2 times 1 over 5 is 2 over 5t minus 4, and that's what I've got, 2 over 5t minus 4. That's the derivative of the velocity one. Now I make the acceleration after 5 seconds. I just put a 5 in there. Well, 5 times 2 over 5, the 5 cancels, 2 minus 4, the acceleration is -2. At -2 meters per second, meters per second squared, that means it must be decelerating at 2 meters per second. Well, I hope that helps.